So now back to the World 3 model. So I already told you the book, The Limits to Growth, which introduced the World 3 model, was published in 1972, but the work that preceded the book and that the book was based on started much earlier. It uses a language called, or a concept called system dynamics that was developed in the 1960s by J. Forrester from the MIT. And it's a methodology and mathematical modeling technique that you can use to build something like the Lotka-Volterra equations. It is used to understand the nonlinear behavior of complex systems over a certain time period. And Forrester used system dynamics to create a model called World 2. And yes, you can probably guess just by the name, it is the predecessor of World 3. Not as powerful, but already going in a similar direction. And system dynamics is a language or an approach that starts with defining so-called levels, or you can also call them stocks, and their corresponding rates or flows. And they also have so-called laundry lists, which specify the set of influencing factors for each of the rate variables. Sounds a little bit confusing, so let's make this a little bit more intuitive by using examples. So what could levels or stocks look like? What could that be? It could be, for example, in the World 3 model, something like a population, where you have inflow to this population variable via the birth rate. The more people are born, the higher the birth rate, the more the population growth, and the population is decreased using a factor which is called the death rate. So that's like one approach for, or one example for levels. And as an example for the laundry list, we can have a look at the birth rate. So the laundry list specifies a set of influencing factors for each of these variables, and what influences the birth rate. It's a population in itself, but it's also, for example, the standard of living. If you are living a super comfortable life and you have everything you need and even more, then you tend to get more children. If you struggle to survive and don't know where you sleep at the end of the day and whether you will have enough food for your family or not, then you tend to, at least on a rational level, to have less children. Same could be said about the food quality or the food quantity. Birth rate is also influenced by education. And of course also by the availability of contraceptives. So this is just like one example for the laundry list of birth rate. Forrester uses the system dynamics approach for his World 2 model, and when he published that, the Club of Rome, which is a non-governmental organization, invites him to apply his ideas to the global economy and ecosystem. He declines and proceeds with the project without the Club of Rome, but one of his former students and a later colleague, Dennis Meadows, organizes the project for the Club of Rome. 17 researchers spend a year refining and enlarging the Forrester World 2 model, and you guess the name or the result is the World 3 model, which is considerably more complex and more powerful. Before we now dive more deeper into the model, please keep in mind we're talking about 1971, 1972. So this, like, you cannot compare what they had back then to what you would assume from a complex simulation or complex model and system nowadays. Please keep in mind that back then computation power was much more limited. Also the complexity of parameters that you could just compute. And even getting information like the levels and stocks or the flow rates that we discussed in the previous slides is like you have to get those information from somewhere, and you cannot just go to Wikipedia or ask ChatGPT. You had to get those numbers, and the accuracy of those numbers and the quality of those numbers were much lower than what we are used to have access to today. So keep all of this in mind while we talk about what they then call the complex and powerful model. In essence, you had 5 major components, which also reflect those curves and lines that you have seen on the previous graph when I introduced you to the standard run of the World 3 model. And if you simplify the model, it more or less looks like this. We have those 5 components: population, agriculture, industry, resources, and pollution. And they have different types of influences on each other. If you look at the resources that we provide you, you will also find a much bigger illustration where they tried to draw really all of the different parameters and how they influence each other on one big picture that looks much more complex than what we have here, but in essence it is those 5 main components that have influence on each other. Those 3 model components are more or less governed by roughly 150 equations, and they cover the time from 1900 to 2100, as we already called, and they are written in a language called Dynamo. So now let's have a look at these 5 model components in a little bit more detail. So first, let's start with population. What's relevant for a population? It's the people, and you have certain control mechanisms to define or to control how the population goes up and down. We already talked about birth rates as one example to increase the population or decrease it using the death rates, but you also have factors that go in there like the maturation. How many people you are carrying from one age category to the next. Because when you think about, for example, productivity in an industrial sense, babies usually are not very productive when it comes to contributing to an industrial society, and at some point you might also retire and then you're not available for the labor market anymore. So it makes sense to have certain age categories. Next, we have agriculture, which is in the model mostly defined by arable land. And the control mechanisms are like the cultivation of new land, by example, like killing rainforests or making other farmland that hasn't been available before available. But you also lose farmland, for example, due to erosion or urban development, which essentially means building a city where previously farmland has been. For the industry, we have a measurement called capital in US dollar that represents something like factories or other productive facilities. And as control mechanisms, we have investment inputs, so inflows, or outputs, outflows, which are essentially depreciation. Just because at some point you invested $1 million into a factory, it doesn't mean that it's still worth $1 million or as productive as a $1 million new factory after 10, 20 years, so it depreciates over time. Now that we have briefly dipped into the details of the World 3 model, let's see what it tells us. But before we go into the actual simulation results, the forecast that it provides, let's have first a quick look at the so-called Forrester's dilemma. When you have a model that you feed with information from the past that you use to give some standard input parameters, but also define how the model behaves, you have a certain forecast time horizon that is relatively easy to predict. So when I start my simulation now of the classroom that you're sitting in and listening to me, it's relatively easy to predict what happens in the next 1, 2, 3 seconds. But what happens in 100 years from now is more difficult to predict. So the closer you are with respect to a time horizon to the point where the simulation starts, the less relevant it is what you predict, because it's usually quite trivial. But the further you go into the future, the more uncertainty you produce, and you have more and more different things that could happen, which then lead to this rather big gap for an uncertain future. So one can forecast future conditions in the region where action is not effective, and one can have influence in the region where forecasting is not reliable. So this is called the Forrester's dilemma, and I would like you to keep that in mind when we move now to the forecast results that the World 3 model provides.